A very good morning to Dr. Kok Boon Cheong and Dr. Eng Lee Fong. My name is Nur Amira Sariati Wintirusai. I'm from Maths 2 and I'll be presenting about my task 3 coursework, which is presentation on the topic of linear programming. So let's start. My table contents consist of some introduction, followed by applications of algebra in daily life, and then model of linear programming, solving a linear programming problem with model, and lastly, some conclusion. So let's start with introduction. Okay. I'll give some snippets of information about linear programming. Okay, this is what we were asked to do. For task 3 of basic algebra and BS 107 course, we were asked to use daily experience to look for an authentic problem. The problem then needs to be solved by linear programming method, and then we have to present all the calculation steps clearly and systematically. So, what is actually linear programming? Okay, the subject linear programming has grown enormously and has found numerous commercial as well as non-commercial applications. So, from reading and solving various of linear programming questions, we knew that it has been used in applications such as food and agriculture, transportation, engineering, efficient manufacturing, and other fields too. So there is one example that I want to highlight is that in the September 1990 newsletter of SIAM, the Society for Industrial and Applied Mathematics, there was one new medical application under a title Cancer Diagnosis via Linear Programming. In that application, linear programming was capable of correctly diagnosing 165 out of 166 difficult to diagnose cases, which would require additional testing. Isn't that just amazing? And then, so in general, it is LP, we call it LP, linear programming, is a simple technique where we depict complex relationships through linear functions and then we solve it. This is just a general review. And then the second is applications of algebra in daily life. Do you ever wonder why do we learn about algebra in school, even now, and is it that useful for us? So let's see. What is algebra? The word algebra is originated from Arabic algebr, which means reunion of broken parts. Interesting, is it? And then, what are the applications of algebra in our daily life? Realizing it or not, we apply the concept of algebra in our everyday lives. One notable example is when solving puzzles. So the concept of algebra makes it easy for us to solve puzzles in a very easy, fast, and efficient way. So this is one of the example. We can solve these puzzles using algebraic way. So can you solve this puzzle using algebraic way? I'll give you 10 seconds. Let's see if we can figure this out. Okay? So you get the answer. The answer is 1. So by using this concept of algebra, we can solve this in just a few seconds, in minutes, very, very fast. And then, other than in solving puzzles, we also use algebra in geometry. We can present a general point by coordinates x, y, remember? And then we also learned that a straight line is represented by the equation y equals to mx plus c. And then there are also other equations that describe several shapes, including circles and more complicated curves. By using algebraic expressions, we don't have to draw all of that. And then the same goes to computer programming. All the games is actually related to algebra. Okay. The third is model of linear programming. What is the meaning of model? Okay, the general structure of an LP model consists of the following three basic components. So the first one is the decision variables are usually denoted by x1, x2. Usually there will be two different decision variables, but it's not possible to be more than that. And then in a linear programming model, all decision variables are positive, continuous, and controllable. That is as stated here. And then the second one is objective function. So the objective function depends on the decision variables because it is expressed in terms of decision variables as shown here. So for this objective function, we need to determine whether it's maximize or minimize. Okay, sometimes it can be the criterion of the optimality can be profit, cost, revenue, distance, and many more. And then the third is constraints. There will always be certain limitations on the use of resources that limit the degree to which an object can be achieved. So the examples of constraints are labor, machine, raw material, space, and money. So such constraints have to be expressed as linear inequalities. And then when we solve the linear programming, then the solution must satisfy these constraints. Okay, let's solve a linear program model problem with model. Let's start with an example question. Okay, so let's read together. Amira is a student, but she also works during semester breaks. She's paid 5 ringgit an hour for working in a bookstore and 6 ringgit an hour for teaching mathematics in a tuition center. For every hour she works overtime, she will pay 2 times the regular salary for working in the bookstore and 3 times the regular salary for teaching the tuition center. But on one condition, both of her employers will only pay her for the overtime hours if it is worth 10 100 ringgit or above for each job. She works no more than 20 hours per week. She spends at least 3 hours a week teaching and no more than 10 hours a week working in the bookstore. Find Amira's maximum weekly earnings. So, the first thing that we have to do when we receive a question, the question is to read the problem carefully. Make sure all the words and ideas are understood. Highlight words and phrases that is considered important and has to do with the calculation. So here we highlight the sentences that we think is important. And then we identify the decision variables first. Okay. So we represent them using symbols x1 and x2. So x1 is hours spent working in a bookstore, x2 hours spent in a tuition center. Okay, which the other way also can. And then identify the objective function, maximize or minimize, right? So the keyword from the example problem, the keyword is maximum. Okay, so we express the objective function in terms of decision variables using the symbol z. So the objective function is maximize z equals to 5x1 plus 6x2. And then we identify the constraints. We translate all the constraints from sentences into the form of linear inequalities. And then we solve the linear inequalities, determine the x1 intercepts and x2 intercepts. So This is the sentence, one of the sentences. 2 times the regular salary, 2 times, and 3 times for teaching in the tuition center, and 100 ringgit or above for each job. She works for 2 jobs, so we times 100 by 2. And then this is the first constraints. And then we solve the constraints by divide the whole inequality by 200 to make this 1. Okay? Because we want the answer in the intercept forms. Okay? And then from here, we know that the x1 intercept is 20 and the x2 intercept is 100 divided by 9, 11.11. The same goes here. This is the constraints for works no more than 20 hours per week. We do the same thing, divide the whole inequality with 20 to make this 1. Okay, this is the third inequalities or constraints. At least 3 hours a week teaching, and then no more than 10 hours a week. Yeah, like this. And then there is also a constraint that is applied to all linear programming problems. This is applied to any LP problem. Okay. So we solve the two variable linear programming method. We use graphical method. So we plot and draw all the linear inequalities constraints on one grid. And then there were 4 constraints, right? So we have 4 lines over here, 4, okay? And then we determine the feasible region that defines all solution spaces of the model. Okay, this one goes up, this one goes down, to the left, up. So this is the spaces that satisfy all of the constraints, okay? And then we solve the objective function. This is the objective function, and then we put in any value. Okay, we substitute z with any value. Okay, after we solve the objective function, and by then we can draw an isoprofit line here. The red one is the isoprofit line. If you see over here, were added to the same grid, and then determine the maximum point by pushing the isoprofit line until it touches the furthest point in the region. So we push the line until it touches this point. Okay, this is the maximum point. Okay, we know the coordinate of the maximum point is 0 and 20. So we can substitute the coordinate of the maximum point into the objective function to get the final answer. This is the objective function just now, and then substitute to get the final answer. So Amira's maximum weekly earning is 120 ringgit, which means in a week she can maximum get 120 ringgit. So we are here at the conclusion. Okay, to sum it all up, linear programming is essential, not just in certain fields such as food and agriculture, transportation, engineering, aviation manufacturing, but also in our daily lives. It actually it actually exists around us. So it makes no sense for us to say that learning about linear programming or algebra is a waste of time. We can apply our knowledge about LP not just in examinations, but also to solve our problems and make difficult tasks much easier. So that's all from me. That's the end of my presentation. Thank you for watching, and thanks and